In this video, we're going to talk about what is social discount rate. So before we do that, let's first look at the initial supply and demand on the capital market. So this mean figure is the supply and demand of the fund. So let's first look at the axis. So here is the interest rate, and here is the savings and the investment. So you will notice that on the x-axis is actually two items. One is saving, the other is investment. A better item will be money, but in a minute we will see why we separate into saving and investment. So let's first look at the problem for the consumers. So the consumer can choose either to consume the income in T1 or in next period, which is T+1. So this is their budget line. Okay, so this slope is their budget line, which is the slope of which is the interest rate. So the savings rate, which is the interest rate. And the curve here is the utility between two periods. So the optimal point is the two that take tangent. So when you change the interest rate, the slope will change. And so at this point, I'm going to consume this much and save this much. Okay, so let's just blissfully saying that, okay, this is I star, so at I star I'm willing to provide S amount of saving. So let's say this is S. Okay, and when you change the interest rate, which effectively is you change the slope, you will have different allocation between this period and next period, which give you different saving. And intuitively, as interest rate goes up, so as interest rate goes up, you will have people want to save more. So it's the supply curve of the money, of the fund, of the loanable fund, which is sloping upward. Now let's look at the production market. So let's say we can, the society can choose between invest the resources now or invest the resources later. And this is what we call the production frontier, and this is an ISO ISO cost curve. So so we would like to achieve the, okay, so we still have a slope and MRTP, and at so we will have investment now and investment later. So when you change the slope, so when you basically change the production frontier or change the cost curve, it will intangent at different points, which will have different slopes and different amounts of investment. So here, so we can map to here. This is also I star, and exactly I want to invest I star. So at little interest I want to invest the capital I. So you can see that the axis is both saving and investment. And seeing if you charge the entrepreneur with a high interest rate, with a loan of high interest rate, he is less likely to invest, or he will invest less. So the demand of the loanable fund is sloping downwards. Okay, so that's enough for the initial graph, and it is traced from the consumption market and the production market. Now, the first thing we need to do is we need to figure out how the government tax changed the figure. Okay, now let's say we do this. Let's say government tax this amount which is let's say it's your capital tax on the dividend yield, which will basically shift the supply curve in, because now the interest rate I got it will be actually lower than the market interest rate, because the government takes a share of the interest rate. Also, now here I'm going to so I'm going to tax the corporate income as well, so which is effectively a tax on the return of the investment proceed, and that is why there will be a gap between the investment return the entrepreneur gets from market and actually what he got to pocket. So now we will have a different optimal level. Okay, this is totally arbitrary. All I want to show you guys is that now this thing has returned to I tax and S tax star and I tax star. Okay. What is really important here is notice that at the optimal level, at the new optimal level, okay, we have a wedge between the P star, which is the marginal preference, marginal rate of time preference for the producer, and R star, which is the interest, which is the marginal rate of substitution of the consumption, which is the interest rate. Previously they are the same, but now they are actually falling apart. And this, the wedge, creates a problem for choosing a social discount rate, okay? Because it's obvious that it is the true social discount rate I star, IT star is neither P star nor R star. Okay, so now after we understanding the wedge, now let's considering a government project that borrows from the market. Okay, so the government project will affect the demand of the loanable fund, because government is kind of like an investor. And let's say we will shift out from the blue dash line to the red solid line. Okay, and now fortunately or unfortunately I get exactly the same interest rate price as before, which is, I assure you, is only a coincidence. Okay, so now this is a new amount of saving and investment, and this is a new interest rate. Unfortunately, it's just the same as the old interest rate. So now how do we actually kind of calculate the I star by P star and R star? So what is being suggested is that we calculate the alpha by a mixture, basically by a weighted average of P star and R star. Okay, WP plus WR. So the weighting suggested is that we weight each part by the proportion of their foregone investment or consumption. So if we have a lots of consumption that is foregone, then we will weight the P star much heavily, which makes sense, right? Because if the consumption does not respond to the interest rate change, then there will be basically no impact on the welfare, and we don't want to consider that. And an argument has been made that the supply curve of the loanable fund is relatively steep, which means people are not, the savings are not very sensitive to interest rate. So that is why in this case, if that's true, then the foregone investment will be much larger than the foregone consumption. Okay, and then that is why alpha will be very close to P star. So that is basically the in a nutshell what the social discount rate is all about. Thank you.